Hi guys, so in this video we are going to talk more about work. So basically when we say work, it is defined differently in physics. In physics, work is done when there is force and motion. So force and motion are the two important variables or quantities in solving for work. So before we proceed to the solving, let's first analyze these variables. So when we say force, of course, we all know that it's the action of pushing or pulling. Okay? And later on, we will know the different forms of forces that we can use in solving for work. And then when we say motion, it's basically known as your movement. Okay? And in physics, there is a movement or there is a motion if there is a change in position. Okay? So in motion, basically you have two different positions. So you have this position or point, and then you have another this position or point. So this point or position is called your initial position or initial point. And this one is your so-called final position or your final point. So if there's a motion, the object or the body will move from the initial position to the final position. So if you're going to graphically show that, so from initial, it will go to the final position. And this line from the initial to the final position or point is called the distance. Okay? So basically, distance is very important for work. So from this explanation, we can say, or we can actually derive the formula for work. And work is simply expressed by this equation. Of course, you need the force. So you can say force, which will be represented by capital letter F. And then, since from motion, we know that distance is also important, so we can include here distance. Okay, so again, capital letter F is your force and small letter d is your distance, or sometimes you can say it's your displacement. So basically, this is the formula for work, and work is represented by capital letter W. So from our general formula, which is W is equal to force times displacement, then we can derive three different formulas, and these formulas can be used according to the nature of the problem or the situation in the given problem. So first one is the W is equal to Fx dx. Basically, you can see here the script x, and x represents the horizontal direction of the force and of the displacement. Basically, Fx means horizontal force and dx means horizontal distance or horizontal displacement. You can use this formula if the direction of the force is horizontal, of course, and if the direction of the force is vertical, then you can use this formula. W is equal to Fy dy. Fy means vertical force and dy means vertical displacement or distance. Okay, let's just write displacement here. And then for this formula, W is equal to force times displacement cosine theta. This is used when the situation is given with an angle, and that angle is basically formed between the force and the distance. Okay, so cosine theta is the angle so cosine theta is your angle, and it's formed usually between the distance and the force. And of course, your F and D are the force and distance respectively. Okay, so let's start with this problem. It says here how much work is done when you carry your 10 Newton school bag from the ground floor to the second floor of your school building. The second floor is 6 meters from the ground. So the first thing that we are going to do is to, of course, write the given values. So given, we have here 10 Newton school bag, 10 Newton, and then 6 meters. Okay, so it says here 10 Newton school bag. So if you're going to analyze that, that is the weight of your school bag. Okay, and we all know weight is also an example of force, and 6 meters, that's the height of the building from the second floor, or I mean from the ground floor to the second floor. So that's basically your distance. Okay, so we can just directly substitute these values in the equation. So we have W is equal to Fy dy, and your Fy is your weight, that's 10 Newton, and your distance is 6 meters, that's 6 meters for dy. So 10 times 60, that will be 60 Newton that meter, or 60 joules. Okay, J means joules, and this is the base unit for work. Okay, so for our next problem, a 25 kilogram sack of rice will be carried to the rooftop of a building. If the building's height is 12 meters, how much work will be done? Okay, so first let's analyze the given values. We have here 25 kilograms. Okay, 25 kilograms, and we also have 12 meters. 12 meters. So if you're going to analyze the problem, 25 kilograms, basically since it's expressed in kilogram, that is your mass, or mass of the rice, or the mass of the sack of rice, and 12 meters is your building's height, and height is a vertical distance. So this is your dy. Okay, so for our solution, we can use the formula W, or work, is equal to Fy dy. Why are we going to use this formula? Because you have there your dy, which indicates your direction. Okay, but our problem here is we have here the mass, which is not a force, but we need the force. So we first solve for the force using the mass. So if we're going to recall the formula of the force, that will be F is equal to m times a, or in here we can say Fy is equal to mass times acceleration. Like our first problem, Fy is your weight. Okay, so weight will be W is equal to mass times acceleration. But since weight is influenced by the gravity, you can say weight is equal to mass times, instead of using A, you can use G, which means acceleration due to gravity, because gravity is influencing your weight. So we can now solve for that. Weight is equal to your mass is 25 kilograms, and your gravity is always, that's constant, 9.8 meters per second, or 9.8 meters per second square. So 25 times 9.8 will give you 245 kilogram, that meters per second, or that's 245 Newton. So it should be Newton because it's a force. So you have now your weight, which is your Fy. So we can now proceed to work. Work is equal to your Fy, that is 245 Newton, times your dy, which is the given value, that's 12 meters. So 245 times 12, you will get 2,940 Newton that meter, or 2,940 joules. For our next problem, a 2,000 gram bottled water will be carried to the rooftop of a building. If the building is 12.9 meters in height, how much work will be needed? Okay, so we're going to solve for the work again. So first write the given values. So given we have 2,000 grams, and then we have 12.9 meters. Basically this is your mass because it's expressed in grams, and this is your dy, or your height. Okay, that's the vertical displacement or distance. So we can now solve for work. Work is equal to force y times dy. So again, we use this formula because dy is already indicating the direction of the force. So for your force, we don't have the force yet. Okay, so you have the mass here. So first let us solve for force, or Fy, and your Fy is, again, that's your weight, or small letter w, and weight is equal to m times g. Now you have your mass, yes, but the problem is it is expressed in grams. So the base unit for mass should be always in kilogram. So the first thing that you have to do is to convert 2,000 grams first to kilogram. Okay, so if you're going to convert that, that will be, okay, let's just make a box here, and let's do the conversion here. Okay, let's convert 2,000 grams to kilogram. So that will be 2,000 grams times bar. So below the bar, you're going to place here the given unit, which is the grams, and then on top of the bar, you're going to place here the desired unit, which is the kilogram, so that you can cancel the gram. So in 1 kilogram, you have 1,000 grams. Cancel. So 2,000 times 1 divided by 1,000, that will be 2, and the unit will be kilograms. Okay, therefore you have 2 kilograms in 2,000 grams. So you can now solve for your weight here. So your mass will be 2 kilograms times your gravity, that's constant, 9.8 meters per second, and 2 times 9.8 will be 19.60 kilogram that meters per second, or that is 19.60 Newton. So this is your Fy, or your weight. Okay. Going back to work, you can now substitute your Fy with 19.60 Newton because that's your weight, or your Fy. So 19.60 Newton times your dy, it's already given, it's 12.9 meters, and that will be 19.60 times 12.9, 252.84 Newton that meter, or 252.84 joules. So this is your work. Okay, so since you already know how to solve for work, we can now proceed to our next lesson, which is all about power. So in physics, power is still connected to work because it is defined as the amount of work done in a unit of time. So it's the amount of work that you will be able to do in a specific time frame. So from that given definition, we can express power in this equation. P, which represents power, is equal to work times time. So this will be your base formula. So let's put number 1 there because that's your first formula. So W is your work and T is your time. P is your power. But not all the time the work is given. Sometimes you have to solve for work first. So instead of using this formula, if the work is not given in the problem, so you can use this formula. P, or power, is equal to, the formula for work is force times displacement. So instead of putting W here, you can say force times displacement over time. So this is your second formula. Okay. For our number 3 formula, it's derived from your number 2 formula. So for our number 2 formula, that will be Fd over T, or force times displacement over time. So if you're going to take a look at this part, you can see D over T. If you're going to recall our previous topic, we know that D over T is the formula used to solve for one quantity, and that is your velocity. So we can also say P is equal to F times D over T, or velocity. So these are the formulas that you can use for power. Okay, so now let's start talking about the unit that we can use for power. Okay, so the base unit for power is watts. Okay, so it's represented by the capital letter W, but you can also encounter some problems where the power is expressed in kilowatts. Okay, so that will be kW. So in this kind of situations, you have to convert kilowatts to watts. You can use this conversion table. So in 1 kilowatts, there are 1,000 watts. Okay, so 1,000 watts. So 1 kW is equal to 1,000 W. But aside from them, there are also instances wherein you will encounter this unit. It's called horsepower. It's represented by small letter H and P. And to convert horsepower to watts, you can use this conversion table. In 1 horsepower, that is equal to 746 watts. Okay, so you have to take note of this also because we'll be needing this in some of our problems. Okay, so let's have our first problem for power. How much power does an object expend when it does a work of 4,000 joules in 10 seconds? Basically, this is very easy. So you just first identify the given values. You have 4,000 joules and 10 seconds. So 4,000 joules and then 10 seconds. So 4,000 joules is work and 10 seconds is... Always take note that it must be always expressed in seconds. So if the time is expressed in minutes or hours, then you have to convert that to a second first. So for the solution, that will be power is equal, and that will be your work is 4,000 joules and your time is 10 seconds. So 4,000 divided by 10 seconds, that will be 400, and the unit for that will be 400 watts. So for our next problem, we are going to use the same situation. How much power does an object spend when it does a work of 4,000 joules in 10 seconds? Express your answer in horsepower. Okay, so the only difference is that we are now going to express our answer in horsepower. So if you can still remember, we get 400 watts for this problem. But first, let's show how to solve for that again. So given you have 4,000 joules and then you have 10 seconds. So this is your work and this is your time. So for our solution, that will be power is equal to work over time, and your work is 4,000 joules over 10 seconds, and you will get 400 watts. So that's the answer. Now we're going to express that in horsepower, so we can use the conversion table that we had earlier. So from 400 watts, we can say 400 watts times a bar, and below the bar is the given unit, which is your watts. So it has to be always below the bar so that you can cancel that, and then your desired unit must be on top. Your desired unit will be HP. Okay, so cancel, and in 1 HP you will have 746 watts. So that will be 400 times 1 divided by 746. You will get 0.54 HP. Therefore, the power that you need for this problem is 0.54 HP. Okay, so for our next problem, I think you're familiar with this because we solved for this earlier for work, but this time we modified it and we're going to solve for the power. So it says here, how much power is done when you carry your 10 Newton school bag from the ground floor to the second floor of your school building in just 25 seconds. The second floor is 6 meters from the ground. So let's first identify the values. We have 10 Newton, 25 seconds, and 6 meters. Basically 10 Newton is your weight, or this is your Fy. Okay, this is your force. It's the weight of the school bag. And then 25 seconds, that's your time. And 6 meters, that is your dy, or it's also the height of the building. Okay, now since we have multiple given values here, we can still use this formula. P is equal to work times time, but since we don't have work, we can use the second formula. So instead of work over time, you can say P is equal to FD times time, because you have your force, you have your dy, and you have your time. So we can use this formula. First, we can now solve for them. Your Fy, or your weight, will be 10 Newton times the distance, which is your height, 6 meters, over your time, that's 25 seconds. So 10 times 60, that will be, sorry, 10 times 6, that will be 60 Newton that meters over 25 seconds. So 60 divided by 25 will be 2.40 watts.